This is the periodic table. The rows are called periods, and the columns are called groups or families. Things in the same column tend to have similar properties or reactivities, other little things that make it so they're kind of like a family or a group. In this particular lesson, we're going to talk about valence electrons. What are they, and how do you use the periodic table to determine them? Helium, over here, is considered a noble gas. It's not very reactive, just like the other noble gases. However, I'm going to move helium, and I'm going to force it to be adopted by a different family. Now, it's been adopted by the second family, or the second group, and we'll talk about why. Helium is incredibly tiny, just like hydrogen's pretty tiny. And hydrogen can only hold, generally, one electron, unless it gains one, but 1 or 2 electrons. Helium generally has 2 electrons, so they are going to be next to each other because this little section represents the first 2 electrons that can enter the lowest energy level. And as we go down the periodic table, we'll see more and more energy levels. As you go down, these atoms have more and more electron orbitals. When we talk about valence electrons, we tend to ignore the middle part and only concern ourselves with the main group elements, which are the tall columns. So let's just count the tall columns from left to right, and that will tell you how many valence electrons are in that family. We have 1, 2, 3, 4, 5, 6, 7, and 8. Just remember, on a traditional periodic table where we didn't adopt helium into a different family, helium always still has 2 valence electrons, even if it's over there on the right. We're going to draw 3 different Bohr models for 3 different atoms, neutral atoms: nitrogen, fluorine, and sodium. So we're going to look at the atomic number. Nitrogen is going to be 7, so it's going to have 7 protons here. Fluorine is going to be 9, and then sodium is going to be 11, so it's going to have 11 protons in the nucleus. Let's draw those in. To make nitrogen neutral with its 7 protons, we need to add 7 electrons. But how are they going to go into this Bohr model? The first energy level can hold 2 electrons. And a clue for that is the first level or row of the periodic table, the first period, is 2 elements wide, the hydrogen and the helium. Then we're going to continue adding the remaining 5 electrons we need to make this neutral. Those are going to go on the outer energy level. 1, 2, 3, 4, 5. Those 5 electrons I just drew, those are valence electrons. Fluorine has 9 protons, so we're going to need 9 electrons. 2 are going to go on the first energy level, and the remaining 7 are going to go on the second energy level. 1, 2, 3, 4, 5, 6, 7. Sodium has 11 protons, so we need 11 electrons to make it neutral. 2 on the first energy level. We have 9 more to go. 1, 2, 3, 4, 5, 6, 7, 8. If we count up so far, we have 10. 2 plus 8. We need 11, and that 11th one is going to go on the highest energy level. Now let's count up the total number of valence electrons, which are now in purple. For nitrogen, it's going to be 5 valence electrons, which makes sense because nitrogen is in the 5th tall column. Fluorine is in the 7th tall column, so it has 7 valence electrons. And then sodium is in the 1st tall column, or the first family or group, and it has just 1 valence electron. But what are these other electrons called? These other electrons are called shielding electrons. So we have valence electrons, which are the highest energy electrons in the outer energy level, or the outer ring, and we have shielding electrons, which are the electrons that are basically not valence electrons. Those are the interior electrons closer to the nucleus.